Video on how the camera works. If anyone has taken my 3D game programming course, you know that the camera itself is very complicated. It's the inverse of the world because what we end up doing is we don't move the camera, we move the world around the camera. If that sounds weird to you, well, wait till you take part 3. If you've already been to that class, don't worry. 2D is far, far less complicated than dealing with creating an inverse matrix for the 3D camera world. The 2D camera world is really nothing more than a draw offset. Since I only have one screen to worry about, that's my width and my height of my view, all I have to do is make sure I draw everything relative to that offset. So let me start by making a new file. Control N. Pound if and def. Someone mentioned in one of the chats that why don't you use the pragma to do your pragma once thing? Because although when that's first started getting used, it was like a compiler specific thing and has since become very standard. I'm old. That's why. The same reason I add the end of line at the end of file is not necessary. I like this. This is the way I've always done it. Is it better? It is less lines of code certainly to do the pragma once. But I like the framing of it. It is purely preference. Ultimately, this is just compiler directive anyway, so you don't have to worry about which one you use because it just the resulting code will be the same regardless. So if not, so I'm going to do camera h pound define. I will tell you I'm not going to make you do one way or the other. Do whichever one you prefer, unless there's a very specific pedagogical reason for me to tell you to do something one way. Your guidelines this semester are to do whatever works. Without stealing. Do it yourself. Don't copy code and claim it's yours. If you copy code, make sure you cite it properly. Like we are using SDL, and you're welcome to use my code, which you don't have to cite. I know I wrote it myself. But if you borrow anything else, some snippet of code you copied off of Stack Overflow, give a little in the comments a citation of where you got it from. That way no one can ever claim that you're trying to steal someone else's glory or violating a kind of honor code. You are welcome to use code off of Stack Overflow, by the way. Just make sure your project is, from the vast majority of it, work of your own. All right, this is not meant to be a lecture on proper etiquette programming. Let's get back to the topic at hand. So we're going to make a camera. Camera is going to be based off of gfc vector.h. Let's save this file as my camera.h. And I'm going to type def struct, not struct parse. Camera. I know I'm not even going to bother with this. I'm not. What I'm going to do is I'm going to create a whole bunch of setters and getters. There's no structure for the camera that we need to have in the header file that anyone knows about. Well, in theory, if you're going to make something with mini cameras, there might be a use case where you would want a camera to be an object that we can instantiate and have individual setups for. But for this simple project, I'm just going to go the simple route. So I'm going to, not even a camera new, I'm just going to have a camera. Let's make the C file now, pound include, simple auger.h, pound include, camera.h, and not end if. This is again, this is entirely unnecessary. I just like it to bookend my files there, like a header and a footer. I'm going to make a global variable, vector 2D, and this is going to be the camera. And I'm going to make this a static variable so that this is a global variable, but it is local to this file. This is not one to be shared around or accessed without consideration. Camera.c, we're in the source folder for the C file. Save. And we're going to initialize this to 0 when the program starts. By the way, a difference between C and C++. C requires the 0. C++ is fine with that. I Okay, so I'm just going to make a couple of getters. I'm going to make a vector 2D camera get position. And we're just going to return the camera. Look at that, that's fancy. If there's a C++, I'd probably make these inlines. Now here's the fun one. I want camera get offset. And I want this to return, not the camera. I want it to return vector 2D of the camera dot x, comma, the camera dot y. Only I want the negatives of these. So this is going to be it's going to be a negative offset. So this is where the camera would be in world space, and this is going to be the offset so that things can be then drawn in camera space. And then ultimately I'm going to have a camera set position. And we're going to take this as a vector 2D position. And we're just going to vector 2D copy. And what did I set copy to? All right, so it's a macro, and it's in dot space. All right. So we're going to copy, and it's A to B, destination comma source, destination comma source. All right, let's make these functions available in the header. And give ourselves the documentation. At brief, get the camera's position in world space. At brief, get the offset to draw things relative to the camera. Set the camera's position in world space. You know, there is probably a reason that we want to have additional information. Let's do that now. So I'm going to go to camera.c again. And I am going to make this a typedef struct camera. And we're going to have the vector 2D position, vector 2D size. So this will be the width and height of the screen. And then I want where's my shapes? Make a rectangle of my X, Y, width, and height. These will be the camera bounds. Keep the camera in here. And maybe let's make a bool bind camera. If true, keep the camera in bounds. You're going to see why all that in a second. So now I'm not going to static 2D, I'm going to static camera, the camera. No, just make a camera. Set the whole dang thing to 0. So now we're going to get the camera dot position. Only I change it to just camera. Camera dot position dot x. Camera dot position dot y. We're going to set to position on camera dot position is now set to that position. And now if camera dot bind camera, now we're going to make sure that the camera is snapped to the bounds. So let's make a new function here. Void camera apply bounds. By the way, this is a methodology of doing a singleton. Once again, we're only ever going to have one camera here. In theory, I could make this so that the camera could be a separate object, in which case I wouldn't have one. I would pass a pointer around. I would need a new and a free and all that fun stuff. So we're going to apply the bounds here, again, on our singleton approach to this. Consider this also a design pattern if you do want the singleton. And again, this is a global variable, so some people go, oh no, global variables are bad. I mean, yes, they can be if they're misused. The same thing why people go, pointers are bad, because yes, they can be if you misuse them. And you should never use go-to statements, but there's a time and a place where they're appropriate. You know, only the Sith deal in absolutes type of a situation here, which of course itself is an absolute. Things exist in these languages for a reason, and there is a time and place for having a global variable. When used sparingly, when used intelligently, when used for like a singleton, this makes sense. In fact, even within my entity system, my entity manager is, where's my entity system? My entity manager is a global variable. There's like one global singleton. I don't need to pass around the entity manager every time I want to do work with it, or I don't need to keep the a reference to it. Even if I made this in C++, this is a class, I don't need to keep it as a variable at some point. I can just, it's part of the system. And it, again, when it's a singleton and a global thing and it's managed, keeping them static, that is when global variables become more appropriate. Just know that doing things like that are sometimes not things like thread safe. Anyway, so if, now we're going to apply camera bounds. Now let's actually apply those bounds. So if, now here, what I'm trying to deal with here. If I have a camera and my right edge is beyond the bounds that have been defined, so the width of my rectangle exceeds my bounds, then I want to snap it to that distance. So if, and this is going to be camera dot position dot x plus my camera dot size dot x, so that's my width. So if this is now together my right edge. If this right edge is greater than my camera bounds dot width, and in fact I can also make sure that this is then plus my camera bounds, or x plus dot bounds dot width. So this is the right edge of my bounds. Like if I say my camera is my screen size, in this case 1200 by 720, but my world is 12 million by 12 million, I make sure that my right edge of my world is going to be what keeps my camera in here. I don't want my camera to look past the world here. So if this, then I'm going to set my camera position.x equal to the right edge minus my camera's width. I'm going to apply the same thought to the height. So in this dimension, all right. Now, because of the way I've set my rectangles where it's x, y, width, height, my x and y are my left and top edges. So checking the other sides becomes much simpler. So if my camera position.x is less than my camera bounds.x, Then I'm just going to snap it into the world so we can't escape, and apply the same thing to the Y. So if my top edge is less than the top edge of the screen, top edge. Now I'm probably in practice always going to keep my 0, 0 to be my bounds so that this won't matter, but this just handles us just in case we design a world that is not 0 centered or 0 cornered. All right, let's make sure this function is in the at least forward bound. Now let's put it in the header file. There could be a time where I want to just set it specifically and then bind it accordingly. At brief, snap the camera into world bounds. Now let's make the other setters and getters and things. So void camera set bounds. And we're going to take a rectangle here. Now I'm going to look in my shape. Rect from JSON, rect, here we are. No, rect from vector, rect shape, rect to vector. There, rect copy. Yeah, rect, there it is, rect copy. That's a macro, that's fun. Wrong place, all right. So my destination is going to be camera.bounds, and we're copying it from the bounds that were passed in. Camera enable binding bool bind camera, and this is just going to be camera.bind camera equals bind camera. Now these two I want to also put in the header file. And then we need to also set our size. So we need this function set to size. Now my camera system, although I only ever have one camera, that camera is a bit more dynamic. All right. Now, when I load the world, now let me make sure set size is in the header file as well. What was I doing here? What was I? Oh yeah, I don't want to do that there. Cool. All right, now I'm going to go back to world.c, and in here, I'm going to include camera.h. So by convention, the named header file of whatever source file we're in is probably going to be to this file the most unstable. So I'm going to assume camera at some point is going to be more stable than world. So that's why it goes in this order. Now, once we have, actually you can put it right here when we create the layer. In theory, I could do it there. In theory, I'm just going to make another function that will set a world of the camera based on the world. Void world setup camera. Just in theory, if I load the world in as a preload, I don't want it to automatically override the camera until I want the camera to be set to the new world space. If not world, return. And now here I'm going to use the camera function to set the world size. Now, and not the size, the bounds based on the game world. And the bounds are going to come from, so this is going to be, what did I call that function? think it's just GFC rect. There it is, yeah. Way to set the XY width and height. Like I said, I'm going to set the upper left corner to be 0, and then this is going to be the size of the world's background or the tile layer. Do I even specify that in when I create the world? Tile width, tile height. What matters is that the tile width and tile height are set, but let's set it tile layer. I need to make sure this works. So if not world tile layer return, maybe I should give myself an error as to why this function is not going to do anything now. This is going to slog no tile layer set for world. So now I'm going to set the bounds based on that. Tile layer is an image, and that image will keep world tile layer. And what are my members of sprite that I want to set here? No, I'm going to have to grab my surface data. Did I clear up the surface data? Does texture give me that information? Let me look that up. Go back to category API. No, let's go back to the SDL wiki. API by name. No, API by category. And I believe that's in this file here. SDL texture. Oh, doesn't give me the data. Boo. Boo. I'll just make sure I keep this surface information around then. So, when I create the layer, build layer. Do I ever clean up that tile surface? No, cool. So it should still be around, but I'll double check that it exists anyway. If not world tile layer or not world tile layer surface, then we fail. Remember, if this is false because it's an OR, the whole thing evaluates to true, and then it won't even bother evaluating this. So this is safe, even though I shouldn't be able to access this if this is null. And what are the surface properties of SDL? I just always forget that. Oh, just W and H. That's handy. Width, comma. All right, so now the world has been set up here. Can even bind the camera with, call this apply bounds. And while I'm at it, let's set enable binding to true. Cool. All right. Now that we have the world will now be applying the camera stuff. Let's in game also set the camera properties. which again, at some point I think is going to be more stable than most of this stuff. So camera.h, where we set the world size after everything else is initialized, I'm going to camera.h set size. And for now, I'm just going to hard code it, but this is 1200 by 720. I'm going to add one more function here, which is going to be void camera center on vector 2D target. Because you're going to see why in a second. This is going to be a useful function to have. So I want the camera centered on what target? I'm going to set the position based on some position here. And I want the vector 2D sub. Let's take a look at what sub does. Right here. Destination equals A minus B. So I want the position is going to equal target minus, well, half of my position, my width. Let's do it out by hand. Position.x equals target.x minus camera size.x over 2. Or, since I believe this is in floating point space, times 0.5 would be more effective. And do the same thing for the vertical. Set our position based on that position, and then let's bind if camera bounds. So let's make this a single line. I normally like to avoid this style, but sometimes it is just cleaner. I find this cleaner than this. Like, just by practice, this is more error prone than this, because this is like one statement, and if I get rid of the thing I want to do, I get rid of the whole statement. Sometimes if I get rid of I don't want to apply the bounds, get rid of the bounds, you didn't realize that there was an if statement here, just because you did it quick and weren't paying attention. Meanwhile, if there were brackets, it just makes it a little bit more human-like to recognize. Anyway. Cool. I'm going to now add camera center on to my player.c. So my player update, after I change my position, I'm going to center on my position. In order for this to work, this file needs to know what that looks like, so pound include camera.h. Let's make, oh no! Unknown type rect. Okay, camera.h needs that shapes file. So shape.h. And world.c. What line was that? 97. Cool. And it's not working. Why is it not working? Now it's a good chance to start giving everything some trace. So let's see, we set the camera size. Loaded. Oh, I don't think we ever set the world bounds based on that world that we've loaded. So where is world.h? I didn't even expose the function. Look at that. world setup camera. Let's put that in the header file. Let's see. It's still not working. No, it's going to cause all kinds of problems later. We'll deal with that later. Oh, I know why. We're not actually drawing anything relative to the camera yet. Let's go back to world, go to world draw. And now I need to draw this to the offset. So I'm going to make vector 2D offset. Offset equals camera get offset. And we're going to draw the background. Actually, I'm going to keep the background unmoving because it'll have a neat little effect there. The background is like a static background. At some point, maybe we'll make this like a parallax effect, but for now, let's just make it infinitely far away so it doesn't really move. And we're going to set this to the offset. I forgot the equal sign, and I add an extra semicolon. I'm really killing it today with my brain. And I need to do the same thing in entity.c. Find draw, entity draw. So there's position. We need a new position. So we're going to vector 2D offset and position. And now we're going to vector, since the offset's already in negative space, we just have to add them together. So it's going to be self position and offset, and well, we're setting it into position. So remember, destination, A and B. Cool. Oh, and we'll need to include camera.h here as well. And there it goes, the camera's moving. It's not working entirely there. Something may have been miscalculated. Also, this is going to fail miserably at some point in time because the screen position of my mouse, which I'm using to guide my player here, this is in screen space, but now the entity is in world space. So that means as I start to pan, like notice how he stops moving, because at this point the screen coordinate for this, for the mouse, is relative to the dude below or above him. So that's going to be a problem. So let me go in and make that adjustment. And let's see if I made a mistake in the camera bound stuff. Apply bounds. So that seems to be right. And if y is less than bounds y equals bounds y, which is just 0. So if these are all less than 0, set them to 0. All right. Let me make sure my player and mouse is going to, play well together. So get mouse state. I'm going to get another vector here. Screen. And screen is going to equal camera get position. And now mx plus equals, I'll call the function screen.x and y plus equals screen y. That should now work better. Cool. The height seems to be calculated incorrectly. Looks like I might have a mistake somewhere when I'm creating this, the size of that. I have discovered a bug. Very likely going to make the layer. All right, create surface. The width is the width tile height times the frame height. Where do we set tile height? Tile height equals height. Let's give myself some output here. Frame height. Do I not set that correctly? It's all based on, where do I create the world new? Width, height, vertical count. Let's go to this. Go to this. This one. Now we set the width and height there. Cool. This is now giving myself some trace. So I'm going to see, I'm going to inspect what these variables say here. So I'm going to say world created with percent I, height percent I, and this is going to be width and height. Width is 20, height is 12. That should be correct. Tile layer is percent I, comma, percent I large. Oh, have I? No, I haven't done that one yet. I need to do that after I create the world layer. Okay, here. Width times width, height times height. Either way, height and width should be the same. All right. Oh, I did actually set my frame width and height to the correct size here, so I guess I didn't have to access the surface directly. Actually, I wonder if that's the issue. Did I make a mistake when I set the camera? Yes, I did. And now we're bound to the world. And if I want to go to my config file and add some more height to it, or some more horizontals to it, wish this dude was faster. There we go. And it stays relative because everything's operating within its same space now. The mouse, when the player entity is checking where the mouse is, it's checking the mouse is relative to world space. And then we're all now drawing as an offset from camera space, so we stay in screen space. And now it looks like the mountain is infinitely far away. All right. So there's our camera tutorial. Hopefully this was helpful. Thanks for watching.